In this lesson, we're going to tackle the integral of x squared times the square root of 1 minus x squared with respect to x using substitution. Let's start by writing down the integral we need to evaluate. Initially, this integral might seem a bit tricky due to the presence of the square root of 1 minus x squared. However, with some clever substitution, we can simplify it. For this integral, trigonometric substitution is often recommended when dealing with sqrt of 1 minus x squared. We can set x equal to sine of theta because it simplifies the square root term. Let's make this substitution. Next, when we make these substitutions, our integral becomes sine squared theta times the square root of 1 minus sine squared theta times cosine theta d theta. Recognize that the square root of 1 minus sine squared theta is simply cosine theta. This is due to the well-known trigonometric identity. Sine squared theta plus cosine squared theta equals 1. Thus, the integral simplifies to sine squared theta times cosine squared theta d theta. This can be further simplified using a trigonometric identity for products. Recall that sine squared theta equals 1/2 times 1 minus cosine 2 theta, and similarly cosine squared theta equals 1/2 times 1 plus cosine 2 theta. Substituting these into the integrand, we rewrite this as 1/4 times 1 minus cosine 2 theta times 1 plus cosine 2 theta d theta. Now we know that 1 minus cosine of 2 theta times 1 plus cosine of 2 theta is simply 1 minus cosine squared of 2 theta, which can be rewritten as sine squared of 2 theta. Thus, our integral further simplifies to 1/4 times sine squared 2 theta d theta. To integrate sine squared of 2 theta, we use another identity. Sine squared x equals 1/2 times 1 minus cosine 2x. Substituting this yields 1/8 times 1 minus cosine of 4 theta d theta. This integral can be computed easily. We integrate 1/8 d theta minus 1/8 cosine 4 theta d theta. The integral of 1/8 is 1/8 theta. The integral of cosine 4 theta is 1/4 sine of 4 theta. Thus, this results in 1/8 theta minus 1/32 sine of 4 theta plus c, where c is the constant of integration. Finally, we substitute back to x, where x equals sine of theta. So, theta is the arcsine of x. Thus, our final integral is 1/8 arcsine of x minus 1/32 times sine of 4 times arcsine of x plus c. And there we have it. We have successfully evaluated the integral by using trigonometric substitution. This is an effective technique and very handy for integrals involving the square root of 1 minus x squared.